Okay, I'll just. I get the answer key pulled up so I can go through it.
Good.
Remember what I need to show.
Testing. All right, that seems to be working, which is good. I'll be back in a second. Maybe another minute or two.
Okay.
That's right.
You care if I pull up GitHub on your machine?
Yeah, go ahead.
Okay. So I would get all this pulled up so it's easier to walk through it.
Oh yeah. You were able to get it?
Yeah, I'm just getting that. Making sure I have all the line numbers of the code pull up so that this is easy to go through.
I'm gonna have to take off it shortly before 11 because I have to meet with Sheila. But
Okay, I think we'll be done.
I don't have everything.
Yeah. Oh, okay.
I think it's. See if anybody's joining. Let's check and see if anybody's joined yet.
Okay. Let's see here. Oh, there we go.
Okay, perfect.
Let me open up one more file. Okay. Great. Well, welcome to the office hours. And I'm going to go ahead and start the office hours by walking through assignment 1, which should be due by now. And I'll double check that got this pulled up. 1 second here. And I'll just, sorry, 1 second while I pull this up here. Okay, so now let me share my screen and I will walk through solution assignment 1. Okay, just to double check, can everybody see the browser window okay? And just, if you could quick post to make sure that everybody can see the browser. Or
Want me to
Yeah, if you can
Double
check
check.
it, that'd be great, Doug.
Sure.
Or if you're here and you can see the browser, please let me know.
Loading.
Okay.
Yes.
Okay. All right, great. So I'm going to go ahead and walk through the solution to assignment 1 and talk through the vulnerabilities that were present in this application and how they worked, and what you want to look for when you're doing the peer grading. Okay, so I'll go ahead and make this a little larger. Some people said it was a bit small. All right, so the first vulnerability in the assignment was you were recommended to go and look through some vulnerability description. So I'll go ahead and pull up the description. So one of the things that was talked about were some vulnerabilities in the Facebook SDK, for example. And the vulnerability that was discussed was about logging. So in older versions of Android, it was possible to get access to all of the log statements that were produced by other apps on the device. And I think the original intent for this was to be able to allow people to create apps that did an interesting thing with logs and debugging for other apps. But it had the unfortunate side effect that if other apps logged sensitive data to the log, then it could be captured by apps that shouldn't have access to it. So in this case, on line 382 of the app that we were looking at, this I Remember implementation, the developers, to help themselves, went ahead and added a log statement to print out the location of the device into the log. And the problem with this is that other apps, if they have the log permission, but they don't have access, fine-grained location permission, they can still get fine-grained location by going and listening to the log statements that are being produced by this app. So on line 382 here, when this app is printing out its location, it's actually dumping sensitive information with the log that it has access to. And other apps without the appropriate permission for location can get access to that, access to the device's location when they shouldn't have access to it. And so this was one of the first vulnerabilities that was present in the application. And if you use the vulnerability checker app, it was just basically looking for these log statements and then using them to figure out where the device was. So any questions about that before I move on? Let's see here. Okay. All right, looks like no questions on this particular one. All right, I'll go on to the next vulnerability and we can talk through them. All right. One of the next vulnerabilities was related to the typing of security state. So when you build an interface or you build a API that somebody else is going to use, you want to try to make sure that they can't inadvertently make a type mistake or a bound mistake on the values they provide you that isn't caught, preferably at compile time. So there were a bunch of examples in the video lectures on this, and this is a pretty direct mapping of the video lectures to this assignment. So in this case, the issue is that we have this use of the storage utilities class and its get output media file, which determines where data gets stored on the device. Now, in this case, we're going to be storing the login information, which in itself probably isn't a good idea to be storing in a file in the app. But there's a very specific problem or bug that's going on right here. And the problem is that this storage utilities get output media file format, it actually doesn't know anything about this parameter that's being passed, which is max security. So if you look up here, the developer has defined max security to be integer.max value. And so their intuition is similar to what was stated in the videos, is they're thinking, oh, a higher value for the integer must mean more security. When in this case, it turns out that that's actually not what's happening. So if we go and look at the actual get output media file format, we see there's this flag that's an int for security. And if we then go down and look, we see that we've got very specific definitions for those integers. So we've got security private, and then if it's not security private, it's going to get stored on the external file system, which on certain versions of Android makes that a public file. So any app could go and read and write it. So this code, depending on the version of Android that you're using, could end up inadvertently linking the login credentials for the user, because this person has created max security and then they're using max security down here, and it's actually an incorrect value for the security flag that's passed to the storage utility. So what happens is they pass in max value for, or integer.max value for security right here. And then when we get to this if statement, it says if security equals security private. Well, if we go and look at security private up here, security private is value 1, not integer.max value. So what happens is that it decides, well, it should be public, which obviously is exactly the opposite of what we want for storing the login credentials. And the result is that we end up storing it in a public directory, where other apps can potentially get access to it. The next vulnerability that we'll talk about is we'll look at the storage utilities class. So the first thing we'll look at is if you go back, and we can see that, and this is related to the same thing, our way that we're allowing people to express the security that they want applied to files is by passing an integer. And we've defined 2 integers here, security public, security private. And again, this should map pretty directly back to the videos. And there's a couple problems with this. One, we're not having any typing, and we can't guarantee that people are providing a valid value for us for the security, as we just saw in the previous vulnerability. Another issue that we've got here, and then later down here in the in this if statement, is that here what we're doing is we're setting the default value to public. So if someone fails to initialize or fails to assign the value and they just pass a security value, well, the default value of an integer in Java is 0. So the default security is always going to be security public, which really isn't probably what the user may have intended. So really what we should be doing is defaulting security private to 0 and security public to 1, or preferably not using integers at all and having something that's much more strongly typed and easier to check. So this is definitely a problem. The next issue that we see is down a little farther. We see that we have a default of storing things publicly again. So if somebody doesn't expressly say that they want something security private, meaning they get exactly the right value and pass 1, then the default for everything else is going to be storing things publicly. And depending on what they pass in for the type, it will be stored in different places in a potentially public location. So this is, again, an issue with some secure defaults being used. Now we'll go on to the last, and what's interesting is this is actually one of the trickier bugs, and I'll pull up a news story from today that just came out on Ars Technica. So if you go and you see Ars Technica today, there's a headline story, Android security on the ropes with 1-2 punch from researchers. And if you dig down into this a little bit farther, they talk about the stage fright vulnerability that's been discussed on the forums for a while. But there is also a new exploit that they discuss, says separately from security firm MWR Lab, disclosed a flaw that allows malicious apps to break out of Android security sandbox. And if you click on that link to the disclosure of the vulnerability and how it works, well, this is taking a while to load, so maybe we won't get to see it in a second. But it's a very similar vulnerability to what we're going to see here. So I'll go ahead and open this, and then I'll talk through the vulnerability in the iRemember app, and then we'll try to go back and see how it relates to this new vulnerability. So the problem with this code right here is on the line 56 of the manifest. And what it is we have a sound record activity. And the way that this sound record activity is used is that anybody can send a intent to the sound record activity and ask it to go and store, basically record sound and then store the store that file somewhere. Now, the problem with this is that by default, activities on Android are not exported, meaning other Android apps can't just come along and send them intents arbitrarily, and which is really what the intent of the developer was in this case. They didn't mean for another app to be able to come and record sound and store it through this activity. Now, the problem is that when you add an intent filter to an activity, if you haven't explicitly set exported to some value, then what happens is that the activity automatically, the default value for exported changes if you have an intent filter to true. So by adding this intent filter for time zone change, which is innocuous, this developer was just thinking, oh, I want to listen to time zone changes. They don't realize it, but they're actually creating a security vulnerability, because now this sound record activity has become exported. And since it's exported, other applications can send intents to this activity, cause it to record sound, and then save it to a file that they have control over. So this is an example of a privilege escalation vulnerability. And you want to, it's a very sort of subtle bug, but it's causing a significant potential issue. An app that doesn't have any permissions can now possibly record sound and get access to the user's private conversations or anything else that's going on. Now, the interesting thing is this new vulnerability that I just read about this morning. So I haven't looked at it in detail, but from the surface, it appears to be a very similar type of issue, is that there's a Google admin. Let me just double check how this looks, because this is pretty small font. Yeah, it's pretty hard to read, but I'll try to highlight the right sections of that. So the problem with this is the Google admin application has an exported activity that accepts an extra string called setup URL. Now, what this means is the Google admin application has an activity that is exported, just like we're talking about, and is allowing other apps to communicate with it via intent. And in this case, what another app can do is being very crafty about the data that it provides in the setup URL. It can use the Google admin application to read files that are private files of other apps and of the system itself. Since the Google admin application probably has root privileges or some very high set of privileges. I don't know the exact set of privileges for the admin application off the top of my head, but I'm guessing it's the privileges that are equivalent to the system service or something very, very privileged. So by sending an intent to the Google admin application, they can trick the admin application into reading a file and getting them back the contents. So it's a pretty serious vulnerability, and it's very directly related to this intent filter and export issue that we see here. So before I go on, I'm going to go ahead and stop for a second here and try to take any questions that people have, if I can get back to the original screen. All right. Okay, so now I'm going to go ahead and go back and take some of the questions So there's issues with seeing the screen. All right, let me start off here. You said it was forbidden to store developer passwords and such on the device itself, either in external but also in internal storage. But when my user password for, say, OpenWeatherMap is in the APK, it resides safely there, or where else can I store them? So this is it's important to differentiate here between user passwords and developer passwords. So let me give you an example of this. If you're a developer and you're creating an app that's going to have a backend service in Amazon's cloud, Amazon gives you a set of secret keys that you need to access your account in their cloud. So as a developer, you might think that you could go and just embed those secret keys that you as the developer own into your app that gets distributed to other people. But the problem is that if you put your developer information into your APK and then hand it off to somebody else, they can easily go and disassemble your APK or investigate the file system on their device or do other things to extract your credentials. So as a developer, when you create something and you put it into the APK, you need to be very careful that you don't put your private information into the APK. Obviously, your code is sort of your IP that you're handing off to someone, and it's not fully private either. But these things like passwords and that you have to be really careful of, because you shouldn't embed them in your APK. Now, if it's let's say you have a user password for your app, and you want to cache it on the device, so that whenever the app loads up, it can automatically use that password to log into your backend server. A lot of apps do things like that, and there's arguments about whether or not it's a good thing to do or not. And you can debate it both many ways. There's also some different facilities on Android to try to help you store things securely. But when we don't have time to get into them in the class, but you'll see hopefully some examples of how to store things like OAuth tokens securely on Android in the assignment 3 that we're going to give you. We're going to give you some skeleton code that shows you some of those things. But it's really important to remember that your developer information isn't private if it goes into your APK. All right, looks like another related question. You can unpack an APK. Absolutely. You can not only unpack an APK, you can decompile it down to source code and get Java code back out again. And you can rewrite it, which is what a lot of malware will do. They'll take an APK that's legitimate, they'll unpack it, they'll rewrite its source code to include a malicious payload, and then they'll re-upload it to one of the app stores. And they've got all of the original developer stuff there, like a great weather app or a Facebook clone or whatever it is, but they've added a malicious payload. So APKs, although they look secure, aren't really something that's secure. You can still mess with them in all kinds of ways. The only thing you can really do is use the signature checks to know if 2 APKs came from the same developer or not. Can we get the source code of the vulnerability check app? I don't believe that we're going to release the source code for that, just because we want to be careful about being able to use some of these assignments again, and also we don't really want to necessarily show the attacks being exploited. What is the appropriate way of fixing the intent vulnerability, removing the intent filter, or adding additional permission? For the purposes of grading of the assignments, I think it's fine to give people credit for either one. There's different ways, and it's hard to say what is the right way, because some of it actually depends upon the other intents of the developer. Now, if you remove it and it doesn't cause any compile errors, doesn't change any functionality, maybe that's the best way to fix it. Maybe that's what the developer really intended, and this was just left behind. You might want to, change the permissions that are available, add a new permission so that somebody could invoke the sound record activity from another activity, but you have expectations on and it describes what's going to happen, so that when somebody can accept whether or not they want to give that permission to that other app. So any of them could potentially be the right solution, and then for the purposes of grading, either of those are fine, and you should accept it. But really, it takes a little more context to say that the absolute right way, if there was only going to be one right way, it would take a little more context that we haven't really provided in this assignment. Let's see, we have another question about that. My approach to fix line 56 of the Android manifest file was to declare custom provision to users of the I Remember app and to enforce that permission in the sound record after. Is this approach valid? Absolutely, it's a fine approach as long as you provide the appropriate description of what that permission is, so that people can make an appropriate security decision about it. And sometimes you may not want to declare a custom permission. Maybe you want to redeclare or reuse existing Android permissions and expect the caller to have them. Or you may want to create a new permission if there's additional semantics, and it really depends. Skype got in trouble with a bug like this that they had, where the Skype app allowed other apps to send intents to it to place outgoing calls. Well, suddenly that was a really big problem, because you would have a user who really didn't understand that they're installing a wallpaper app, but suddenly it could use Skype to get access to the microphone and also to place outgoing calls to numbers they can control. So these types of vulnerabilities, that's some case where it probably made sense for Skype to have a specific permission to make an outgoing call that they should have been aware of. Okay, we've got that one. Exported equals false is okay. That's also another potential solution to this. Adding a custom permission that has to be had is certainly fine again also. So let's go ahead, and since we're getting a bunch of questions on the solution, let's go ahead and dive into the other piece of this. So again, for this one, multiple ways to fix it. One would be to get rid of the intent filter if it doesn't break in anything, make it exported equals false, add a custom permission or some other permission that has to be had. Multiple ways of fixing this vulnerability, and any of them should be given credit in this case, since we didn't provide additional detail. So the next issue that we need to go look at is the login activity problem. And again, there's going to be a wide variety of ways that you could fix this. One of the simplest ones would be to refer to the actual correct value to store it privately. We could go and actually look at the storage utilities, and we could realize that this security private is what we want and refer to it. So that would be one of the simplest fixes, would be to just swap this to refer to security private and store it privately. You could remove this line if you do that, because you're not going to need it anymore. You could also do more complex changes if you wanted. Anything that basically goes through and makes this so it uses the correct value is a valid solution to fix this. We didn't want it to be an extensive refactoring of the app to make it simple, since it was pretty tricky for a lot of people to get the vulnerabilities, and then fixing them is also another step. We just wanted to a reasonable solution that ends up causing the right flag to be passed in this method is okay. If they do something really fancy and refactor more, that's okay. But our expectation was that the fixes that people were going to apply would only be in these two files, and we partially scoped it that way just to make it so that from a grading standpoint, it's going to be easier to say whether or not it's fixed or not, and going and looking at these files. Now, you could do much more extensive refactorings to make a better app, but we weren't expecting people to do that in this case. Okay, I'll go back here for more questions and go ahead and see if there's anything else about the existing assignments, and then if not, then I'll go on to the other questions. What are the mechanisms for storing secrets and other secure data in-app? It depends on what the secrets are. If they're developer secrets, there's not really a good way. If you package it up and you put it into your APK, or it winds up on an end user's device at some point, as a developer, you should assume that your passwords or anything else that you provide in an app are going to be compromised. If it's the user's data, it just depends on the sensitivity of it. So if it's data that gets created in your app, but you don't want other apps to read it, maybe it's text notes, for example, that your app is creating. Well, your app could certainly just store those text notes in the private storage of that app, and that could be an okay solution. And I say I'm going to give a lot of examples because there is no one right answer of what is appropriate. Since, for example, if you're storing text notes about credit card numbers, then probably just storing it in the private storage of your app is not a viable solution and not a valid solution. You should really be doing something much stronger. If it's text notes about the user's calendar, maybe it's not a big deal. Or what websites they like. Maybe it is or isn't a big deal, and maybe you're okay storing it in the private storage. There are also facilities for storing things in Android, and I alluded to this, and I don't want to talk about it right now because we don't have an example code, but I'll come back to it when assignment 3 is released, which should be next week. And in the office hours next week, I can talk a little bit more about some examples of ways of privately storing OAuth tokens and things like that. But the short answer is, most things can be, if you store it on the device, you have to really assess how sensitive that information is. Do you want the user to have access to it or not, the user who owns the device? Are you just trying to protect it from other apps on the device getting access to it, or are you trying to protect it from anybody who, let's say, steals the device and gets physical access to the device? If it's people who get physical access to the device, well, then it becomes a much harder problem trying to protect it. And so the right answer really depends on a lot of different factors that you have to consider, and the threat models that you have to consider about what you're trying to protect and how valuable it is, and whether or not somebody's going to have physical access to the device, or they're just going to have an app on the device, or they're going to have network access. There's varying considerations. And so I don't want to boil it down to one right answer, because it really depends. And I'll talk about some of the other ones again next week after assignment 3 goes out. If I can't put personal data in my app, where can I store it? Now, again, we want to divide this up. Personal data of the developer of an app is different from personal data of the user of the app. The developer of the app should never put their personal data into an app that they're going to distribute. The user of the app, again, it depends on the sensitivity of that information, how you're going to store it and protect it. You could store it in private storage on the device. You might encrypt it and require the user to provide a password. You could do all kinds of things. And that, these are all things that you have to consider. And it really depends on how sensitive that information is. Okay. The deadline for assignment 2 shows August 28th. Just wanted to make sure if that was right. Are we going one extra week to complete assignment 2? Yes, you were given more time for assignment 2 because we thought it could be a little bit trickier depending on, how much you had from the previous assignments and how well you'd done. So I wanted to give a little bit more extra time to do that app. It wasn't just 2 weeks for it. So yes, you're correct. Okay, assignment 2. We use a hard-coded user details service that OAuth 2 uses. Which classes and patterns do I need when I want to make a user details service from persistent storage? Great question. So let me go ahead and try to pull up some code here that we could look at for that, and try to dive into code. So if we go and look at the auth, so basically what you would be doing is, where is it? It's not here. Let me pull up. Well, actually, we can start here with user. So this user class, if you're thinking about how would you put this in the database, one of the first steps would be you'd want to take this user class and annotate it with the appropriate JPA annotations so that you could store it in the database. And you'd probably need to refactor it a little bit to have a no-arg constructor. But you'd want to annotate this thing so that you could go and store these objects in the database and have like the username, for example, be the unique ID of each of these objects when they were stored in the database. If you're using Spring Data, then you'd want to go and create like a user repository. So you could go and look up the user objects that you had created and stored in the database. And Spring also has some implementations of these things for you. But assuming you were doing it all on your own, you would then want to go and where we have this user detail service and we're creating an in-memory user detail service, you would want to create your own user details manager that basically would read from the database and read accounts out of the database so that we weren't just hard coding a bunch right here. So most of it would be going and creating your user class and annotating it with JP annotations so you could store it in a database, creating a repository so you could search for them in the database, and then create an implementation of this user details service interface, which I believe Spring also provides a default implementation that if you give it a repository will also work. But even if you're creating your own, this is a pretty straightforward interface to go and implement if you have your user repository. So you would just replace this with your one that actually pulled from the database. And then for the client details, depending on if you wanted to have these roles or you wanted to use other roles and clients, you could go and do something similar for the client details service where you replace these with things that were coming from a database. But most of it's about going and just sort of creating equivalent models that implement these interfaces but store things in the database instead. Okay. We did not get the email notification for this virtual office hours. Okay, that's good to know. We'll double check why that didn't go out this time. Why is the video file manager different than the one in the previous MOOC? I'll be honest, I didn't even realize that it was slightly different. So I'm going to go ahead and see if I can pull it up real quick. Let's see here. Which here's assignment 2. And that's probably just a slip up on our part that we used a slightly different one. Hopefully they're functionally equivalent. It must be in controller, video file manager. Either one would have been perfectly fine. Let's see here. My guess is that the one from the previous MOOC, this one is using some Java 8 features around files and paths. So my guess is that the one in the previous MOOC, we weren't using Java 8 yet in any of the examples. And so we did the upgrade to the Java 8 one, and that was why we didn't use it in the previous MOOC, is because it was from a prior offering and where we hadn't offered the Java 8 version. Could we have a vulnerabilities compilation that would really help with grading? Yeah, I guess, are you just looking for, I guess, a list of the vulnerabilities? So the list of vulnerabilities that should be corrected are in the manifest file, line 56. They need to either remove the intent filter if it doesn't break anything, or do any of the above that'll fix it. You should be able to do exported equals false, add a custom permission, require some other permission related to sound recording. Any of those things should be viable answers. In the login activity, what they should be doing is taking the call to get the path where the file is going to be saved, where they're using max security. They should replace max security with an appropriate value. So those are going to be the two places that you're going to be peer grading, and that's going to be the Android manifest. They should be fixing that privilege escalation, and in the login activity, they should be fixing that passing of that max security variable, which is an incorrect value for private. How do we reset the JPA repo? I'm not sure what you mean by reset. If you're just looking to clear out all the data that you've had previously, if you use the approach that I posted on the forums of adding those parameters to the URL of the JDBC connection URL, I believe is where they were placed, then they're storing all of the data in the I believe a data directory, and you could delete that data directory, and then next time the app or next time the application starts up, it should recreate it. Otherwise, if you mean reset it in some other way while it's running in memory, you would have to go through and like use the repositories to delete all the objects in it. Really depends on what you're meaning, but you can follow up with more details in your question in the forum, and I'll try to help out. We still have not gotten any news about the certificate of the previous MOOC. Yes, we have been asking and trying to get those grades released. My understanding is that they should be released today, and that there was a slip up in the grading that we had asked for them to be released over 2 weeks ago, 3 weeks ago. Our understanding is they'll be released today, and we apologize for that delay. Should be corrected hopefully today at the latest. Okay, well, the third assignment is going to go out next week, and will be due roughly a week before class is concluded, and then we'll have another final 6 days or so to do peer grading of it. Again, we really appreciate you coming to the office hours and tuning into what we're doing. Discussing the answers to quiz 1. Okay, let me go through that real quick. I walked through the vulnerabilities, but I'll go ahead and walk through the specific answers to the questions. So let me just pull up a complete list of the lines. So on question 1, it should have been Android manifest line 56, which, as we showed, was the place where the intent filter was accidentally exporting the activity. Question 2, the correct answer would have been to check create story activity line 382, which, let me open that up if I don't have it opened up already. Get down to line 3. Right here on create story activity line 382, it's using a log statement to print out the current location of the device, which unfortunately on older versions of Android is allowing other apps to read the location of the device without getting access to the location permission of the device. Then for question 3, everything should have been left unchecked. For question 4, everything should have been left unchecked. For question 5, it should have been login activity line 48, which I'll go ahead and pull that up here. I think I had it open. We'll go ahead and login activity line 48. It's here where they're passing in the max security variable, which is an incorrect value and ends up causing this file to be stored publicly. So login activity line 48. For question 6, nothing should have been checked. Question 7, storage utilities line 24 and 76 should have been checked. So line 24 here, where they're setting the default to public, and then line 76, where, oh, sorry, where is it? Where am I missing it? Ah, there it is. Line 76, where the default location, if it's not private, is being set to public. Those were the correct answers for question 7. Question 8, nothing should have been checked. And question 9, nothing should have been checked. Okay. Yep, and the quiz answers, I just went through those. Any other questions? Great. Well, thank you for coming to the office hours, and we'll get this virtual office hours video posted soon today. Thank you.